in the idea of similarity. Okay. So similarity is a little bit different to congruency. Can anyone tell me who has done similarity in class? Can anyone sort of tell me what the difference is between these two things, between similarity and congruency? Who feels brave and can talk me through a bit? Oh, naughty. Okay. Talk me through the difference between these two concepts.
Ma'am, congruency is when the triangles are like exactly the same.
Good.
And then similarities is when there are similar angles or whatever in the next.
So close,
triangle.
so close. Yeah, okay. So just be careful with your wording, but you're definitely on the right track with that. So 100% Unati, congruency, they have to be identical. They have to be exactly the same in every way. But in similarity, the angles also have to be identical. So like this angle has to be the same as that angle, and this angle has to be the same as this, and this one has to be the same as this. So if the angles are the same, what do you think? What can you tell me about the sides?
They're different sides.
There are different sides. I'm looking for a very specific word here. It is on the screen at the moment. Do you think you can find it for me?
They're proportional.
Yes, there we go. Awesome. Okay. So similar triangles or similar shapes, they have exactly the same angles, but the sides are in proportion. Okay. So it means that they're not the same. Basically, imagine you've put something like a picture on somewhere and you've just dragged it. Like, you know how you get that little corner thing that you can drag in a picture to make it bigger or smaller? You're enlarging the triangle or you're making the triangle smaller. But so it's not exactly the same size, but the angles on the inside are exactly the same. Okay, so that's all that this is saying up here. This first part is just saying that they have the exact same angles. So we call them equiangular, and we would write that as A. So all three angles which are the same as each other. And then the other thing is that the sides are in proportion. Okay. Let's see if someone can explain this to me. Who thinks that they can explain what it means? You can use these two triangles here as an example if it will help you. But what do you think it means for sides to be in proportion? Because that feels like a very fancy thing to say. Can anyone sort of explain what's happening with these two triangles, looking at the sides? Maybe that will be able to explain what in proportion means. Sort of the same size? Well, I mean, sort of. What do you see, like look at the relationship between these two different numbers. I'm going to highlight some things for you. So I'm like going to highlight those two, and I'm going to highlight those two, and I'm going to highlight those two. Neo, yeah, okay. So what Neo is saying is that like all of the sides in this triangle on the left, if we multiply them by 2, so 3 times 2, that's going to give us 6. And 3.5 times 2, that's going to give us 7. And 4 times 2, that's going to give us 8. So we would be multiplying them all by the same amount. Exactly, Marcus. They are enlarged by 2. Okay, they're being doubled. Singer, how can I help?
Ma'am, I have a question.
Oh.
Is it like the same, like, ma'am, by saying times 2, is it the same as saying like the ratio like between them always stays the same?
Yeah, exactly. The ratio stays the same. So if you were to write a fraction, like let's say I wrote a fraction as 1/2, okay? Would you agree
Yes,
that that fraction would be exactly the same as 4/8?
Yes, ma'am.
Okay,
Oh, it makes sense. Yes, ma'am.
exactly. I'm just multiplying them both by 4, but they're the same. So that's exactly what's happening here. Proportion just means that they're all going to be going up by the same amounts, because if we wrote it as a ratio, it would be equal.
Yes, ma'am.
Nice. Good question. Okay, so on the right-hand side, we're just looking at some rectangles over here. Sorry, I didn't mean to ask to unmute you there again. On the rectangles, it's the exact same situation. Our angles are all exactly the same because they're all 90 degrees. And then our sides have been multiplied by 2. And so our sides are in proportion. Okay. And so these shapes would be similar to each other. I'm going to move down just now. So if you would like the screenshot of this page, take one now. If you have any questions about what you're currently seeing, ask now. And then I'm going to move on down. Cool. Okay. Okay. So similarity has a symbol which is very similar to congruency, except that congruency are our 3 lines that are horizontal, and similarity are 3 lines that are going up. So just a reminder for everyone, those 3 lines, that means congruent, okay? And congruent means that they are exactly the same. So I could cut one shape up and I could put it on top of the other shape and it would be identical, okay? So these 3 horizontal lines, those are congruent lines, and these 3 vertical lines, those are our similar lines. So I'm going to draw 2 little triangles over here. Okay, they're not my best triangles, but I'm trying. Also, if anyone broke up today, like from school, let us know. If you're already on holiday, we'd love to know. Okay, so I've got 2 triangles. Let's call this ABC and DEF. Okay. In these 2 triangles, using the symbols that I've used, I've shown you that those angles are exactly the same as each other. Okay. Yeah, Titipocho, if I'm saying your name wrong, let me know. How can I help?
Ma'am, I can't see the first triangle. It's
You
like
can't
half.
Are you on your phone?
Yes.
Okay. Does that help?
Yeah, that helps. Thank you.
Okay, no problem. I'll keep it sort of more on the right-hand side then. I can see where you're on holiday. Sona's been on holiday since Monday. Guys, I'm so jealous of all of you on holiday. I'm tired. I'm very tired. I'm ready for a holiday. I want to be sitting on a beach. Okay. Yeah, me too, Singer. So these triangles, they are not congruent to each other. Obviously, you can see the one is much bigger than the other one, okay? But they do have the same angles as each other. So what I'm meaning is those are the 2 lines and those are 2 lines. So that angle is the same. And this has got 1 line and this has got 1 line. So those angles are the same. And these have got 3 lines and these have got 3 lines. So that angle is the same. Okay. So if I wanted to say that these triangles are similar to each other, I could say triangle ABC is similar to triangle. Now, do you think you can help me finish off the sentence? I want you to keep in mind how we have to write our triangles. Think about congruency. Yes, Tristan, beautiful. Okay, we want to write them so that the angles match each other. So we can see that angle A is the same as angle D, and we wrote A first. So we're going to write D first, okay? And then if we look at B, B is the same as E, so we're going to write E second. And then C is the same as F, so we're going to write F last. And so all this sentence is saying is that this triangle is that symbol, remember, means similar. Okay, so it means it has the same angles. This triangle is similar to this triangle. And it's so important to get the ordering of these right, because when we're working with ratios, it's important for us to know which angles are the same. And this is telling us that angle C is the same as angle F. And it's telling us that B is the same as E. So if we don't write it out like this, we can make some big mistakes when it comes to working with ratios later on. Okay. So that's sort of just how we would write that those 2 triangles are similar. Anyone have any questions about this? Or feeling stressed or anything? Let me know. Okay. And remember, if you're too embarrassed, you're welcome to send us private messages. All right. So the size doesn't matter. No. So the size doesn't matter. This, like, it can be a huge triangle and a tiny, 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 tiny triangle, as long as the angles are the same as each other. Yes, the order of the letters matters a lot in similarity. The order of these ones don't matter so much. You could put that in any order you like, but then this one needs to be corresponding. So I could have said triangle BAC is similar, but now I need to think, well, B is the same as E. So I need to start E first, and then I'm going to have D, and then I'm going to have F. So they have to be corresponding to each other. Okay. Cool. Cool. Guys are so quiet tonight. I'm not too sure what to do with it. Okay. In this little picture, I'm trying to think of how I can get this in so those of you on your phone can still see. Okay. I've got two triangles that are chilling over here. Okay. I'm telling you that they are similar. I would like you to write them in the correct order. So let's just do that part first. So at the moment, we're going to ignore this part of the instruction. We're going to do that just now. I would just like you to write these two triangles in the correct order to each other. If you were to mix up letters, yes. So it depends. If it's like at the beginning of the section, your teacher might be a bit lenient, a little bit generous, but towards the end of the section, then absolutely you would lose marks. And as you move up into the higher grades, you would definitely lose marks. Yeah, and then you can quickly pop up there and you can take a picture. Okay. All right, so I'm just wanting you to write these two triangles in the correct order for me. So which triangle is similar to which triangle, and make sure you get your order correct with all of the letters. And you're welcome to write your answers in the chat for me. And then if we have someone who is feeling confident, pop that hand up and we'll go through it together. Chikondi, nice. I'm liking that a lot. Singer, are you feeling confident?
Kind of, ma'am. So I said triangle FGH.
Triangle FGH
is similar to triangle STR.
Perfect. Okay, let's put this in here. So we're going to say triangle FGH is similar to triangle STR. Okay, perfect. I love it. Great. While I have you on the line, let's see if you can do the second part of this. The second part of this was saying, can you give us the value of X?
Yes, ma'am.
Okay.
The value of X would be 9.
Why?
Because, ma'am, the value of 5, oh, how do I explain this, ma'am? But
no,
they say
trust yourself.
They said 5 times 3, and that was 15, and then 4 times 3, and that was 12. So meaning also 3 times 3 is going to be 9, ma'am.
Yes, yay, well done. Nice job. Perfect. 100%. Okay, so we're using proportion, we are using ratio in order to find our missing side. Okay, so first thing all we did was we said which two triangles were similar and where they were similar. So we were careful with our letters, and then just worked out that it was 9 by multiplying either side by 3. Beautiful. So well done. Anyone feeling confused or questions? Don't be scared to ask. Okay, cool. Yeah, Namaza. Oh, Namaza, do you have an update for us on your test situation?
Sorry, ma'am?
Do you have an update on your assignment?
Doing nothing about it, ma'am. They said the marks are already in the system, and I was so angry. Yo,
I'm sad.
you don't understand. I wanted to fight so badly.
I'm so
Like I
sad.
was ready. Sorry, I was gonna say, do you mind like quickly like just like re-explaining? Because like the thing kicked me out.
Oh, okay. So the first, are you happy with writing that the two triangles are similar to each other?
Yes, ma'am.
Okay. And then, so is the only explanation you want to me is how to find x?
Yes, very much so.
Okay. So when two triangles are similar to each other, their sides are in proportion, which means that if I had a triangle and this side was 2 and this side was 4, then I've multiplied it by 2, right? So they are in proportion.
Ma'am?
I've increased them at the same rate as each other.
Yes, ma'am.
Okay. So here, if I look at these ones, I can say, well, this side was 4, and if I multiply 4 by 3, I'm going to get to 12. Okay.
Yes, ma'am.
And if I have 5 and I multiplied that by 3, that's going to give me 15. And so if I multiply 3 by 3, that's going to give me 9 centimeters.
So is 3 going to be a scale factor?
Exactly. In this particular situation, 3 is our scale factor.
Okay, thank you so much.
Okay. Sure. Hold on, let me just go through these questions here. Can you make the diagram clear? Yeah, I can. I'll make it a little bit bigger for you now. You can take a screenshot. Is there a specific way we have to write the reason? So yes, we haven't learned how to write the reasons yet. Remember in congruency, we had 4 cases of congruency. While we're on that, can anyone tell me what my 4 cases of congruency were? You can write them in the chat for me. What were my 4 cases of congruency? Yes, SAS, I like it. RHS, SSS, one more. SAA, yes, good. Okay, so when we're talking about congruency, okay, our 4 cases are RHS, SAS, SSS, SAA. Those are our 4 cases of congruency. In similarity, we only have 2 cases, and we're going to learn about them now. Okay. I think for whoever wanted the picture, I'm just going to try and erase some of my drawings, and that might help a little bit. Hopefully that's clear on your side. So just be careful. AAA is not a case for congruency. You'll see it's not chilling over here. It is a case for similarity. It's going to be the one of the ones we're going to talk about now. Okay, cool. Okay, so we have 2 cases for similarity. Case 1 is AAA. So if they were similar, we would write this as, well, actually, I think you guys are all doing quite well. Can you just tell me what my sentence would be here? How would I write that this triangle is similar to this triangle, and then giving the reason of AAA? What would that look like? Who thinks they can tell me what that sentence would look like? Just be careful to get your letters in the right order. And as soon as you feel confident, either pop it in the chat for me or just raise your hand and you can tell me how to write this. Okay, so we've got A, B, C, and PQR. Yeah, I like it. Okay, so we can say triangle ABC is similar to triangle PQR, and our reason is going to be AAA. So they have all 3 angles are the same as each other. That's how we would write that. So for who was asking earlier about giving the reasons, this is what that would look like. Okay, so that's case of similarity number 1. Case of similarity number 2 is that the sides of the triangle are in proportion. Okay, so I know that this looks a little bit scary. What is AAA specifically? So those A's, each A stands for angle. So that's basically saying angle, angle, angle. They have got 3 angles that are the same as each other. If that makes sense. So like this angle is the same as this angle is the same as this angle, and this angle is the same as that angle. Okay, and then the second one is sides in proportion. This one comes out less regularly, but it does get given in tests and exams. And this is just meaning that basically what we've been looking at. They've been multiplied by the same amount, right? So if this side was Z, there's my Z, I'm multiplying it by K. This side was X, I'm multiplying it by K. This side was Y, I'm multiplying it by K. So I'm just multiplying it by the same thing each time. Think of it like this. Let me not draw on that side because I think some of you might not be able to see. Let me just draw two triangles. So like if I had 2, 3, 4, and then I had 8, 12, 16, right? All that's happened is I've said 2 times 4. So in this case, my K would be 4, 3 times 4, and 4 times 4 to give me these other numbers. The sides and proportion just mean I can multiply them all by the same amount. If I had like a 10 chilling over there, that's 3 times 4 is not 10. And so in that case, these are not similar triangles. And I wouldn't be able to say that they're similar. So I have to be able to multiply all of my sides by the same amount in order for them to be similar. Okay. And then I would be able to write like triangle ABC is similar to triangle PQR. And this reason is a bit of a schleb to write out, but we write sides in front. So the K is just like saying, it's like just a random variable. It could be anything. It could be Y, it could be B, it could be A. It's just saying that it's the same amount. So I'm multiplying all of my sides in the one triangle by the same amount. So imagine K was 2. I'm multiplying them all by 2. Or K could be 4. I'm multiplying them all by 4. So it's just meaning that I'm multiplying all my sides by the same number. That's all it means. Yes, exactly. Exactly. So if we have a look up here, this one, they told us that those angles were the same. So if I wanted to give a reason here, I would have said AAA. But if they hadn't told us that those angles were the same and they had given us this 9, we could have said that they were similar because of sides being in proportion. How do you get the value of the letters? Okay, so for the letters, we're just trying to see, we're trying to get them to be in the same order as each other, okay? So if I have a look here, I started going from A to B, which means I was traveling along the line that was X, and then I traveled along the line that was Y. So I'm first going to travel along the line that's X, and then I'm going to travel along the line that's Y. So we're kind of traveling through that. So I'm starting at A, I'm going to B, and then I'm ending at C, A to A, B, C. Starting at P, going through X, then Q, and then R. So we're trying to get the same sides as each other as we're moving along. And then if we wanted to find what the different sides would be, they would have to give us more information. They would have to give us something in order for us to be able to do that. Do we have any questions? Any confused bears? Can you give me an idea? Just give me a number from 0 to 10 where your mind is sitting with the stuff right now. Okay. I love the half marks. The half marks always like, they make me giggle. Like, what's the distinction between 8 and 8.5? Singing nice. Okay. 7.5. You know, a little more than 8. Okay. Okay. Well, I think from here we should go down to our brain break, and then we can try and jump into a few more questions, see if we can start figuring some things out. See where we go. No, it's okay if you're late to understand load shedding is affecting us all. So our brain break today, guys, is something different. I think you'll like it. This is going to be our first trial. If you hate it, you hate it. Just let me know. But Brian has brought you a special treat today, and we'll see if you agree with his treat or not. No, don't be scared. It's fun. I think it's fun. I mean, maybe you won't think it's fun, but I think it's fun. Okay, so Brian has brought you this treat. I'm just going to explain the treat that Brian has brought before I jump into it. So Brian thought, shame, you guys are like on holiday, or like you're about to break up, and so you've had like enough maths and you've had to listen to me talk about similarity. And so he thought he'd bring you something a bit different today. So what Brian has brought you is, it's called, oh, sorry, Renee, this is Brian. This is Brian Brain. His surname is Brain. He's personified. This is Brian Brain. Welcome. Exactly, Brian the Brain. Brian the Brain has gotten something a little bit different. So basically what he has is there's two today. There's a picture of something that has been super, super, super zoomed in. And you have to figure out what that picture is. And then when you figure it out, then I'll show you what the picture looks like when it's zoomed out. Okay, so there's two of them. Let's see if you guys can figure out what they are. Okay, so picture one. What is this? No, not lemons. It's close. Sugarcane, no. Brush. Ah, yes, we got there. Okay, cool. Cool. This was your introduction into it. It is definitely spaghetti. It is spaghetti. No, so Miss Yolanda just had to take today. Don't worry, she's coming back. She's not gone forever. And Nicole is just standing in for us today because Yolanda couldn't be there. So this first picture was definitely spaghetti. Nice job. Okay, cool. That was your introduction one, because I was worried that you guys would panic. So that one was our nice, easy one. We've got one more, which I think is a little bit tougher. But I don't know. You did that one so quickly that maybe this next one you'll also get super quickly. We'll see. Okay. But spaghetti is not the same as macaroni. Macaroni is like short and curly. It's a type of pasta. And then spaghetti is like a long type of pasta. They're like two different types of pasta. It's like a curly C, macaroni, I think. Saying it kind of is. No, macaroni looks super different. I'm gonna put pictures of macaroni on our lesson on Tuesday. Like just make a little macaroni border so that we can all see if we're on the same page. Okay, next one, let's see. No. I love the person who just said ew. Why is this ew? Yes. We have the right answer. The right answer has come in. I'm not going to tell you what it is yet, though. I want you to, but someone in our chat has gotten the right answer. I still don't know why it's ew, though. And what about this looks like fish? Okay, so our winner is Tatenda. Tatenda got it first. It is 100% a cup of coffee. It's just super zoomed in on those bubbles. Gross. No, man. Nicole, did you not guess that? Where were you?
No, not at all. It was looking like a fizzy drink. I was on that train.
On that page. Nice job, though. Tatenda, good work. It looks like creepy eyes. Creepy eyes. Well, now I hope that when you guys next have a cup of coffee, all you see is like creepy fish eyes staring back at you. That's what my hope is. Let's go with heart, because heart is nicer. How do we feel about these zoomed in pictures? Do we like them? Do we not? Do you want to have more of them in the future? Do we not? We love it. Okay. I don't have more for us today because it's a quiz day, so I don't want to take up too much time, but I will bring more on Tuesday. Okay. Cool. I'm glad. Cool. Let's jump back in. You did super well, guys. Okay, so these questions, there's only 2 of them. More of this with a dingbat. Okay, I'll see if I can try and combine those 2. Okay, so in the questions below, there are 2 questions. You're going to state whether the triangles are similar or not. So you're going to look at them, and you're going to tell me if they are similar. And if they are similar, you're going to give their names in the correct order, and then you're going to tell me the size of X. Okay, so I want you all to look at these 2 triangles. I want you to figure out how you would write those triangles in the right order if they are similar, and then I want you to try and find the value of X if they are similar. So everyone get going on that. When you are happy with your answer, you're welcome to pop it in the chat for me. And if we have someone who wants to talk us through, that would be great. Just pop your hand up and we'll go through it. We'll see how you go. Okay, Renette, I like that order so far. Oh, okay, Singa, I'm going to give this to Afazola because we've heard from you already today. I'm just trying to share the love around a little bit. So let's see. Afazola, can you talk us through? How would I write this?
Okay, ma'am. Can you hear me, ma'am?
Yeah, perfectly.
Okay, ma'am. We will say triangle ABC is similar to triangle PQR.
What is my reason for that?
Well, A, ma'am.
Yes, yes, good. I mean, you had a 50-50 chance there. Nice. Okay, A. Perfect. What is my value of X?
You will say 4 times 3, that is 12
Perfect. And what are my units?
centimeters.
Thank you. Otherwise, it could be like wheels of cheese. We don't know. Be careful with your units.
Yes, sir.
Nice job. Perfect. 12 is perfect. Awesome. Guys, yes. Did you find this easy? I'm hoping you did. Give me an indication. Yes. Good. Okay. Perfect. That's what I like to hear. Let's try our next one then. So our first step here is you are telling me whether or not these are similar. Don't you need a reason for 12? So the thing is, for the 12, you've just proven that they're similar. When we do a proper similarity proof, I'll show you where we would put those reasons. But for the moment, this is fine. You can just tell me that it's 12. Aka, I will, when I go through B, I'll go through it super, super slowly. If they weren't similar, you would just say this triangle is not similar to this triangle. Atlahan, that's what I like to hear. Namaza, I do see your hand and it will go to you. I'm just giving everyone a chance to finish it off. But I see you. Oh, sorry. Okay. Ask away, sweetheart. I'm here.
Sorry, ma'am. Are they translated?
Okay. So translated is, so when we're looking at transformations, right? So then things
Yes,
can be translated, rotated, all of that vibe. That only ever happens if we're on a Cartesian plane.
Yes, ma'am.
So you could say that this triangle has been rotated, like it's not in the
Okay.
same space as the other one, but it's not a word you would
Yes,
have to use. You only have to use those words if you're on a Cartesian plane.
Yes, ma'am. Thank
Okay.
you.
Sure. Okay, let's have a look. Come on, hello, can I help? Oh, not can I help? I think you have the answer for me looking at the chat. You just need to unmute on your side, and then we'll be able to hear from you. There you go. Hello.
Hello, ma'am. Yes, ma'am.
Hi. Okay,
Eh.
talk me through your answer.
Can I try, ma'am?
Absolutely.
Yes, it is ABC
Okay, triangle ABC.
is
Yeah.
similar to triangle FDE.
If just be careful with D. So I love that you started with F.
Yes, ma'am.
So do you see how B is 60 degrees over here?
Yes, ma'am.
So which one do you think would be the next letter in the second triangle?
I think it's E, ma'am.
Yes, there we go. Okay. And then what would my reason be?
I think SAA.
Okay, so in similarity, we only have two. So we only have AAA, and then we have sides in prop. Okay. If we have this one, then they have to have given us all three sides. Okay. So when looking at this, have they given you all three sides, or have they given you all three angles?
I think all
Let's-
three sides.
Okay, so let's have a look here. So this over here, that's 60 degrees. Is that an angle or is that a side?
It is an angle.
It's an angle. Good. Okay.
Yes, ma'am.
And we knew that that 60 degrees is the same as the 60 degrees, right? So that's an angle. Then let's
Yes,
look
ma'am.
over here. We've got this 50 degrees here. Is that an angle or is that a side?
Angle.
Good. Okay. And that's the same as this one, which is the same as
Angle.
the angle over there. Good. Okay. And then we've got this one over here. We've got 70 degrees. Is 70 degrees an angle or a side?
Also an angle.
Also an angle. Okay.
Yes,
So
ma'am.
when we look at it like that, what would our reason be?
It AAA.
Exactly. Do you see why?
Yes, ma'am.
Okay, good, 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 good. Okay, now that you have figured that out, do you think you can tell me what my value for X would be?
I don't think so, ma'am.
Okay, no, that's fine. That's fine. I'll move on to someone else. Very well done for trying. You did good. Nice. Okay, let's have a look. I'm just going to pop down in the hands and see if I have any hands of someone I haven't heard from today. Oh, Imbo, we haven't heard from you in ages. Okay, can you help me find X?
X, ma'am, I got X equal to 12 centimeters.
X is equal to 12 centimeters. Can you explain why?
Because I saw that 4.
Yeah.
I saw that 2 times 3 is 6 centimeters.
Good.
So then I just said 4 times 3 is 12 centimeters.
Perfect. Nice job. Perfect, perfect, perfect. It is exactly 12. Okay. So if we're having a look at this, try and get a highlight out and highlight the sides that are sort of corresponding to each other. And then we would be able to see, okay, well, that would be 4 times 3, which is going to give us 12 centimeters. Okay. I can't remember who had a question in our last one. And I said I was going to explain this one slowly. If you still are uncertain, can you just send me a message? If it's a direct message, that's also totally fine. What if you had to say side 6 and side? Okay, so we couldn't compare these two because they're not corresponding to each other. So this 6 centimeters is in between 70 and 60. And this 4 centimeters is in between 60 and 50. So they're not corresponding to each other. We have to look at which ones are in the same position as each other. Cool. Atazola, is this a question or is your hand
Yes,
up?
ma'am.
Question.
Yes,
Okay.
ma'am, it's a question.
Sure.
Ma'am, when can I say sides similar in proportion?
They have to have given you all three sides in order for us to use that rule.
Can you explain further, ma'am?
So like imagine, I wonder if I had one here. No, okay. Okay. If I had a triangle like this and a triangle like this, and this was 2, 3, 4, and this was 4, 6, 8. Okay.
Yes,
So
ma'am.
they haven't told us any angles. We don't know any angles. But
Yes, ma'am.
we can see that 2 times 2 is 4. We can see that 3 times 2 is 6. And we can see that 4 times 2 is 8. We could say
Yes,
these
ma'am.
two triangles are similar because their sides are in proportion.
Okay, ma'am.
Makes
Thank
sense?
you, ma'am.
Okay.
Yes, ma'am.
Cool. Cool, cool, cool. Singer, is this a question?
Yes, ma'am, it's a question.
Sure.
Ma'am, I would like to know, ma'am, when you like doing like this thingy, okay, is it always going to be a multiplication, ma'am?
Sort of. we're gonna slowly venture into where we start dealing with some fractions, but only towards in time.
No, ma'am, but I mean like for example, this 2 centimeters that became 6 centimeters. Couldn't it have been like, is it only going to be 2 times that, ma'am, or can it be 2 plus 4?
No, so it can't be plus or minus, but it can be times or divide.
Oh, okay, okay, thank you.
Okay, no problem. Come on, Halo, can I help?
Yes, ma'am. Hey, ma'am. The 3, ma'am. Where does it come from?
Okay, so when we're looking at this, we're trying to start. Okay, here I'm comparing these two sides that I've highlighted that are yellow. Okay, and I've got
Yes,
a
ma'am.
2 on this side, and then I've got a 6 on that side. So how did I get from 2 to 6? I said 2 times 3 gave me 6.
Oh,
And so then when I'm looking at my purple side, I'm saying, well, 4 times 3 is going to give me 12, which is going to be my X.
okay, ma'am. Thank you.
See. Okay. Palesa, you are doing Yolanda's voice very well there. I like it. We've got her spirit with us. Okay. Oh, we have a sneaky. I thought I only had 2, but we have 3. That's great. I like it. Okay. Let's do this last one. You are going to tell me if these are similar or if they are not similar. And if they are similar, you're going to put them in the correct order for me. Let's see how this goes. So you're going to tell me if these are similar or if they're not similar. I'm just going to move this here in case anyone wanted a picture of both. So you're going to say if they're similar, if they're not similar. You're going to put them in the correct order if they are similar. You're going to give me a reason if they are similar, and then you're going to find X if they are similar. Oh, Tracy's saying I don't think they're similar. Let's do a poll. So if they are similar or if they are not similar, at the moment, we have got one person on the side. Okay, Renate is saying that they are, oh, well, Renate's saying that they're equal, which we have to talk about. But I'm going to put it on the side. So if you don't, okay, we've got another addition here. Okay, Belinda's saying no. Angela saying no. Namaza saying no. Kejo. Ishmael. Where to? Renata's staying strong here. Yes, Iman, that's totally fine. Hope. Okay. Okay. Tatenda has joined Renate. Tristan has joined Tatenda and Renate. Okay. Similar? Not similar? Oh, looks like we have a winning side. I don't know where we're gonna end on though. I'm gonna give you 30 more seconds to vote. And then I'll let you know who our victors are. Okay. So before I tell you who's won, we're going to think about a triangle, and all of our sum of angles in a triangle have to equal to 180 degrees. So if I say 180 minus 88 minus 48, I'm going to get 44 degrees. And if I say 180 minus 88 minus 44, I'm going to get 88 degrees. And if I do that, I think you'll see that this angle is the same as that angle. This angle is the same as, oh, I've written 88.
Oh, 48 there, teacher.
Losing my mind over there. Oh, here we go. Okay. And this angle here is equal to this angle here, which means our victory goes to those of you who said that they are similar. They are definitely similar. They have all the same angles as each other. This is a classic example of where the popular opinion is not always the one you got to follow. So they have exactly the same angles, which make them similar to each other. And so then if I was writing it as a sentence, I could say triangle ABC is similar to triangle EFD because of angle, angle, angle. Yeah, exactly. Props to Renette, who stood strong despite all the people coming in saying not similar. Big well done to you guys. Now that we know that they're similar, can you tell me what X is going to be? Tell me what X is going to be. Think about what we've done to get from 3 to 1.5. Singa, is this an answer for me?
I'm going to try, ma'am.
I like it. Okay, tell me what you think it's going to be.
Ma'am, I think it's going to be 3.6, ma'am.
Oh, you are multiplying by 2. What did
Yes,
what?
ma'am.
Okay, so.
Oh, ma'am, we are dividing by, oh, okay.
Yeah.
We are, we are dividing, ma'am.
So what's that going to land up being?
Okay, ma'am, let me do my calculation. It's going to be 0.9, ma'am.
Perfect. You got it, guys. Nice job. Perfect. Well done, guys. I have to